Welcome to this explainer where we are fully decoding the ultimate insider playbook for mastering the Cambridge computer science exams. Whether you're tackling syllabus codes 0417, 0478, 0983, 0984, 2210, or the notoriously rigorous 9618 AS and O level, if you've ever looked at a past paper and felt like you were just staring into the matrix, you are exactly in the right place. Today, there is no paper. There are only patterns. We're going to strip away the confusion and look at the actual code behind every single question. I want you to imagine two totally different candidates sitting in the exam hall right now facing a brutal past paper question. Let's say a classic from the 9713 archives. First, we have Alex. Now, Alex is smart, but Alex completely overloads the page with raw computer science facts. We're talking a massive wall of text detailing everything they know about arrays, but with absolutely zero actual analysis. Then, right across the aisle, we have Sam. Sam is panicking. Sam rushes through, completely missing the command word requirements, and basically just rewrites the question. I've got both of their flawed answers right here, completely covered in red pen marks from the examiners. By the end of this session, you are going to know exactly how to avoid their mistakes and write the kind of answer that turns that red ink into green check marks.
We've got a structured masterclass today covering 5 crucial sections: the 15% secret, the theoretical framework, the methodology, the top 3 examiner warnings, and finally, our signature deconstruct, solve, evaluate system.
Section 1, the 15% secret. Let's look at the absolute high stakes in paper 2. We are diving straight into section 11.1, programming basics, and specifically the absolute essential skill of implementing pseudocode from flowcharts. Why are we zeroing in on this? Because this single topic accounts for a massive 15% of your total marks in paper 2. Let that sink in for a second. 15%. That is not just a few bonus points. That is literally the difference between scraping by and achieving absolute mastery. It's the equivalent of jumping an entire grade boundary just for mastering one specific domain. But here is the catch. This is exactly where our candidates Alex and Sam fail. Alex sees a flowchart and dumps out the entire history of loop structures. Sam sees it and just writes, it loops until x is greater than 10. Neither of them gets the marks. Before we continue and reveal exactly how to fix this, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, this perfectly illustrates the difference between average students and those top 1% performers. Look at the left. Generic answers built entirely on rote memorization. That's Alex. On the right, we have connected conceptual understanding that is actually transferable to unfamiliar context. To beat the Cambridge system, you have to decode the command words. If the command word is evaluate and you just describe, you get 0, nada. This is where we introduce the Peel framework: point, evidence, explanation, link. Top students structure every single analytical answer using Peel. They make a specific point about the algorithm. They provide evidence directly from the trace table. They explain why that impacts the program, and they link it back to the command word in the question.
Section 2, the theoretical framework. These are the underlying rules of the matrix. The entire syllabus, whether you are doing IGCSE 0478 or A-Level 9618, is built on these 3 specific assessment objectives: systematic analysis of problems, evidence-based reasoning, and deep mastery of fundamental concepts. Let's do a quick 30-second challenge right now. Imagine 2 answers. Answer A says, the array is inefficient. Answer B says, the 1D array creates a bottleneck because a linear search is required, evidenced by the sequential indexing in line 14, which increases time complexity as data scales. Which one follows the Peel framework? Obviously, it's answer B. Answer A is our buddy Sam rushing. Answer B is systematic evidence-based reasoning. The examiner literally cannot deny you the mark when you lay it out like that. So, the crucial transformation happens when you follow this standardized procedural sequence. I call this the computer science success blueprint. Step 1, identify key elements. Step 2, apply relevant principles. Step 3, execute the analysis with incredibly clear working. Step 4, verify your results. Imagine taking Alex and Sam's failed papers right now. I'm taking my green pen and we are rewriting them live. We force Alex to stop info dumping and just identify the key variables. We force Sam to slow down and actually write out the step-by-step working. Suddenly, those red marks start transforming into green check marks. Your mark potential jumps from 0 to 100% just by adhering to this strict 4-step execution sequence.
Section 3, the methodology. It's time for executing the code. Let's see how this builds in a real practical application.
True algorithmic thinking requires you to basically become a compiler yourself. You have to decompose the problem step by step. You must select the appropriate data structure. Don't use a 2D array if a simple list will do. You implement efficient pseudocode, and crucially, you test it rigorously. Testing isn't just eyeballing it. Testing means drawing a comprehensive trace table, tracking every single variable change loop by loop. This is where the magic happens. This is where you prove you aren't just reciting a textbook, but that you actually understand the logic pathways you've built.
But remember, it's not strictly about writing loops and if statements. You absolutely must master data interpretation. In Paper 2, this means extracting raw data from binary representations, performing complex multi-step calculations, and translating that into evidence-based conclusions. If you try to do multi-step binary shifts or hexadecimal conversions in your head, you are playing with fire. You have to slow down, write out the nibbles, carry the bits, and physically map out each individual step right there on the exam paper.
Section 4. Top 3 examiner warnings. These are the fatal glitches in the system. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Seriously, we need to ask ourselves, what are the specific traps that trip up otherwise completely prepared candidates? It's time for our interactive workshop. Challenge 1. Data scan. Imagine a complex trace table flashing on your screen right now, with variable x incrementing while variable y halves. I'm putting a 60-second timer on the clock. Go. You are scanning the data. What is the core trend? The trend isn't just the numbers changing, it's recognizing that it's a binary search algorithm having the search space. If you can't spot that trend under pressure, you lose the easy marks.
Moving to Challenge 2, find the flaw. I'm going to read a sample paragraph, and you have to identify the fatal flaw based on the examiner warnings on screen. Listen closely. The while loop will iterate until the counter reaches 10, at which point the array will output the values. Okay, time's up. Did you spot the flaw? According to the examiner reports, the fatal error there is ignoring boundary conditions. Does it run when the counter is 10, or does it stop before 10? The candidate didn't specify, so they get nothing. The top 3 fatal errors, literally straight from Cambridge, are forgetting to check overflow, completely missing those less than versus less than or equal to boundary conditions, and providing answers that lack the specific context of the scenario.
Welcome to Challenge 3, Speed Writing. You have 30 seconds to write down why this quote is the most important thing you will hear today. Go. Okay, let me break it down for you. Please memorize this golden rule, the method mark strategy. Showing your working can literally rescue your grade even if your final calculation is a total disaster. So many students act like Sam. They rush, do the calculation in their head, write down a final wrong answer, and score a fat 0. If you show your working, the examiner can see your logic. Process is heavily rewarded here.
Section 5. Deconstruct, solve, evaluate. Let's lock in the final playbook.
Here is the complete computer science answering system. Rule 1, command word decoding. Rule 2, Peel framework application. And when that command word asks for an evaluation or a comparison, you cannot just list facts in a vacuum. Look at the table. You must explicitly detail similarities and differences using comparative connectives, words like whereas, however, conversely, and back up every single one with hard evidence from the prompt. This proves to the examiner that you aren't just reciting a textbook, but analyzing the specific system architecture in front of you. And rule number 3, the time management matrix. You have to allocate your time based on the depth required. To properly evaluate the quality of any algorithm, you must explicitly address its time complexity, how the execution time scales with data, and its space complexity, how much memory overhead it requires. Furthermore, you have to talk about edge cases. What happens if the array is completely empty? What if the user inputs a negative string length? Addressing these edge cases and their effect on performance is the ultimate flex that secures top-tier marks. I want you to take a mental screenshot of this slide right now. This cheat sheet is your 5-step deconstruct, solve, evaluate framework. 1. Identify the given information. Stop reading and start highlighting. 2. Break it into logical steps. 3. Solve systematically, showing every ounce of your working. 4. Check for reasonableness. If your calculated file size is bigger than the entire internet, you made a mistake. And 5. Make justified, evidence-based recommendations. If you follow this, your logic becomes utterly bulletproof.
So, are you going to keep making the same mistakes as Alex and Sam, or will you use the visual story method to encode these patterns and completely master that 15%? Picture the flowchart as a physical journey you are walking through step by step. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.